Am I audible now? Hello? Am I audible, children, now? Good. Right. See, there is a problem with my mobile, so it will shake, so no problem. You can listen to me clearly and you can understand. Okay. We have discussed. See, whenever I ask you a question, you need to give me answers while typing in the chat box immediately. Okay. So if I ask you a question, if you know the answer, you can type that one in the chat box. Right. So the class means in the school we have discussed axioms and postulates. We have seen some have 7 axioms and 5 postulates. I told you the axioms are statements which not required proofs. They are called universal truths. So it means we cannot prove them, but we can feel them. So there are some axioms like this. Equals are added to equals, the wholes are equal. Equals are subtracted from equals, the remainings are equal. Whole is greater than part. Things which coincides the same thing are equal to one another. Things which are equal to the same thing are equal to one another, like this. Things which are half of the same thing are equal to one another. Things which are double of the same thing are equal to one another. So these are the 7 axioms that we have seen with the help of some examples. And these 7 axioms will play a very important role in the coming geometry lessons. And the next one is postulates. There are 5 postulates that we have seen. First postulate is we can draw a line from one point to any other point in a plane. We can draw a line from one point to any other point in a plane. Okay? Suppose there is a point A over here and point B over here. Passing through these 2 points, we can draw a line. Not only these 2 points, we can draw a line passing through any 2 points in a plane. That is the first postulate. And it is having one more supportive statement is also there. Supporting statement that we can draw one and only one line passing through these 2 points. Suppose A is one point and B is another point. Passing these 2 points, we can draw a line, and we can draw only one line like that. Understand? Once again I am giving the statement. Suppose there is a point A and there is a point, another point B which are on the same plane. So passing through these 2 points, we can draw a line. That is first statement. An immediate one is we can draw only one line passing through A and B. Only one line, straight line. Okay, na? So first postulate is that one. Second postulate is that there is a line segment AB which Euclid called it as a terminated line. Line segment, he called it as a terminated line. And what he says, a terminated line can be extended on both directions. This is his second postulate. A terminated line can be expanded on both directions. Okay, now. Only 14 people are there out of 36. How can I teach the lesson? Right. A terminated line can be extended on both directions. Second postulate. Okay. Next one. Next one. Third one. A circle can be drawn. A circle can be drawn taking any point as center on a plane and with any radius. A circle can be drawn by taking any point as center of the circle and with any radius. This is the third postulate. We can draw a circle by taking any point as center on the plane. We can consider any point on the plane as center, and with any radius we can draw a circle. This is the third postulate. Fourth postulate is that all right angles are equal to one another or each other. All right angles are equal to each other. Means the angle between any two perpendicular edges. The angle between any two perpendicular edges is same everywhere. It is same. Its measurement is same. I gave you some examples also in the classroom. Yeah. So the floor and the wall in our house or as well as in the school, the angle between them, both are perpendicular to each other, na, floor and the wall. So the angle between them is a right angle. The edges, the consecutive edges of your table, surface of your table. Observe the surface of your table. Observe the consecutive edges. Angle between them, they are perpendicular to each other. Angle between them is 90 degrees. Understand, children? So, fourth postulate is all right angles are equal to one another. And the last one, fifth postulate, which is very, very important, which is known as Euclid's parallel postulate. Euclid's parallel postulate. Okay. This is very, very important. Very, very important for solving the problems in the geometry. Which indicates, this parallel postulate indicates existence of parallel lines. It indicates the existence of parallel lines. Let us see what it says. There are two lines, L and M, and another line which is intersecting these two lines, making four interior angles, and four exterior angles. Okay. Now, if here these two angles and these two angles, A, B, X, Y, these two pairs are called angles on the same side of the transversal. Interior angles on the same side of the transversal. They are called interior angles on the same side of the transversal. Okay, children? Now, if A plus B is 180, automatically X plus Y is also 180. If A plus B is 180, automatically X plus Y is also 180. No, chuskokala. No need to think about it. Surely X plus Y is 180. If A plus B is 180. Okay? Now, what the Euclid says, If A plus B is 180, if A plus B is 180, that means sum of interior angles on the same side of the transversal is 180. Then these two lines are then L parallel to M. Then L parallel to M. This is what he says in fifth postulate. You can't hear me? Hello? Can you hear me? Camera shaking, leave that. Can't you hear me? Okay. Okay. Now this is what fifth postulate. So children, in this chapter, just you have to understand and by heart axioms and postulates, defined and undefined terms, only that. No need to solve the exercises. Okay. No. Just you solve the exercises, and we'll discuss those answers tomorrow in the classroom. Exercise problems we will discuss tomorrow in the classroom. Okay. Because I don't have textbook with me, 9th class textbook. Let me see once. Let me see that if I have 9th class textbook, we'll go ahead with the problems. Give me 2 minutes. Yes, I have. No, I don't have. Ninth textbook. Aruna, Ashok? Ninth textbook unda? Amma? Ninth textbook.
Ninth textbook. Ninth. Number systems.
Yeah. I find it. Now open your exercise, children. 5.1 exercise. Exercise 5.1, first question. Which of the following statements are true and which are false? Give reasons for your answers. First question. Only one line can passes through a single point. Is it true? Is it true, children? Only one line can passes through a point, one point on a plane. Is it true or false? Suppose there is a point A. There is a point A on a plane. So can we draw only one line or we can draw more lines? We can draw infinite number of lines passing through a point. Is that right? So that is a false statement. So what is the reason? We can draw infinite number of lines passing through a point. That is the reason. Okay. Second question. There are an infinite number of lines passing through two distinct points. Is that right? Is it true? Passing through two distinct points. How many lines can we draw? Passing through two distinct points, how many lines can we draw? According to Euclid, According to Euclid, we can draw only one line. Very good. We can draw only one line passing through any two points. But he says we can draw infinite number of lines, which is false. So second statement is also false. Now, third statement. A terminated line can be produced indefinitely on both sides. A terminated line can be produced indefinitely on both sides. Is it true? What do you mean by terminated line? Terminated line means line segment. Children, tell to your teacher that only 14 students are joined in the class. Only 14. So third statement is true. A terminated line can be extended on both directions indefinitely. Third one is true. Fourth one. If two circles are equal, then their radius are equal. If two circles are equal, then their radii are equal. Yes. Equal means two circles are equal, then the radius are equal, na? What is the reason? We can draw only one circle with one radius. Is that right? We can draw only one circle with a radius. Is that right? Suppose I told you to draw a circle of radius 3 centimeters to Aniket, as well as to one more girl. Let it be Manyata. Manyata, I told you to draw a circle of radius 3 centimeters, and Aniket also I told to him to draw a circle of radius 3 centimeters. Now, after drawing those circles, okay, if we place them one on the other, what we will see, what we can observe? Children, I told Manyata to draw a circle of radius 3 centimeters and cut it. Now the circle of radius 3 centimeters is there in the hands of Manyata. And now I gave the same task to Aniket also. Now that fellow is also having another circle of radius 3 centimeters. Will these two circles are different or the same? You are not giving answers. Are these two circles are same or different? Both the circles are same, because if we overlap them, we can see only one circle. Yes, yes. If we overlap or if we place one circle on the other, we can observe only, it looks like only one circle. So if two circles are having same radii, they are equal. Next. See the figure over there. See the figure. There is a line segment AB, PQ, XY. There are three line segments. It is given that AB is equal to PQ. If AB is equal to PQ, PQ is equal to XY, then AB is equal to XY. Is the statement true? Children, is the statement true? Can you say the reason? Is it true? What is the reason? Yes, if it is true, what is the reason? I want the reason. Which axiom is used here? Which axiom is used here to prove this? Yes. First axiom. Things equal to the same thing or equal to one another. Very good. Here AB equal to BQ, XY is also equal to BQ. AB equal to BQ, XY is also equal to BQ. So things are equal to the same thing. They are equal to one another. Things which are equal to the same thing are equal to one another. Okay, na? Now next question. Next question. Give a definition for each of the following terms. Are there other terms that need to be defined first? What are they and how might you define them? Parallel lines. Parallel lines. Now please tell me, how can we define a parallel lines? In order to define parallel lines, is it necessary to define any other? If yes, what are they and how can you define them? I will give you one example. In order to define parallel lines, first I have to define intersecting lines. In order to define parallel lines, first I have to define intersecting lines. If I know what are intersecting lines, then I can say what are parallel lines. Is that right? Now, intersecting lines. So, intersecting lines, two lines are meeting at one point. They are called two straight lines. If they are meeting at one point, they are called intersecting lines. Now, using this, I can define parallel lines now. If two lines are not intersecting, they are called parallel lines. Even though they are extended on both directions. Even though they are extended on both directions, they will not meet. So, in order to define parallel lines, first we need to define intersecting lines. Is that right? In order to define parallel lines, first we have to define intersecting lines. So, if you know what are intersecting lines, then you can clearly understand what are parallel lines. Is that right? So, two lines which are meeting at only one and only one point. Two lines which are meeting at one and only one point, they are called intersecting lines. Okay. Now you tell me what are parallel lines. Two lines which are not intersecting, they are called parallel lines, even though they are extended. Two lines which are not intersecting, even though they are extended, they are called parallel lines. That's all. So like that you have to define the terms over there. Okay. Now, perpendicular lines. Perpendicular lines. How can we define them? Perpendicular lines. How can we define them? So, in order to define perpendicular lines, what else to be defined first? In order to define perpendicular lines, what else to be defined first? Yes. First, if two intersecting lines, if the angle between them is not 90, two intersecting lines, if the angle between them is 90 degrees, is called perpendicular lines. Okay, na? Two intersecting lines, if the angle between them is exactly 90 degrees, they are called perpendicular lines. So in order to define perpendicular lines, we need to take the help of intersecting lines. Okay, na? In order to define perpendicular lines, we have to take the help of intersecting lines. So how can we define perpendicular lines? Two intersecting lines, if the angle between them is exactly 90 degrees, they are called perpendicular lines. So all intersecting lines are not perpendicular lines, but all perpendicular lines are intersecting. Note this point. All perpendicular lines are intersecting lines, but all intersecting lines are not perpendicular. Note this point in the class book. Okay, now next one, third one, line segment. Line segment means first we need to know about a line. In order to define a line segment, first we have to define a line. What is a line? A line is a collection or arrangement of points indefinitely on both directions. In order to define a line segment, first we have to define a line first. A line is arrangement of points indefinitely on both directions. That is line. Now what is line segment? Line segment is a part of a line which is having two endpoints. So in order to define a line segment, first we have to understand what is a line. Okay, na? Hello? Hello? Can you hear me?
Hello?
Yes. Am I audible now? Am I audible? So in order to define a line segment, first we need to define a line. What is a line? Then from the line, a part of a line segment, a part of a line which is having two endpoints. Part of a line which is having two endpoints is called a line segment. So line segment is a part of a line. Line segment is a part of a line which is having two endpoints. Okay, na? Now next one. Radius of a circle. Radius of a circle means the length by which a circle is drawn. Radius means length by a line segment. In order to define a radius, first we need to understand what is a line segment. Okay, na? So a line segment with which a circle is drawn is called radius. The length of the line segment by which a circle is drawn is known as radius. Next, square. In order to define a square, first we need to understand what is a quadrilateral. Square is a quadrilateral in which all sides are equal and all angles are equal. So in order to define a square, first we need to define a quadrilateral. First we need to understand what is a quadrilateral. So square is a quadrilateral. Quadrilateral means a four-sided closed figure. Is that right? Four-sided closed figure. Okay. Quadrilateral is a four-sided closed figure. Now, is all quadrilaterals are squares? Is all the quadrilaterals are squares? No. But all squares are quadrilaterals only. All squares are quadrilaterals. So what is a square? A quadrilateral with all sides equal and all angles equal. All sides and all angles are equal is called a square. Okay, na? Next one. Consider two postulates given below. Given any two distinct points A and B, there exists a third point C which is in between A and B. Okay. There exists at least 3 points that are not on the same line. See, does these postulates contain any undefined terms? Are these postulates consistent? Do they follow Euclid postulates explained? See, first question. Does this postulate contains any undefined terms? Yes. Points are undefined, na? Okay. Points are undefined. So yes, they contains undefined terms because they are points. Now, are these postulates are consistent? Yes. See, if we are thinking about 3 points, they may lie on the same line or they may not be lie on the same line. Is that right? They may lie on the same line, they may not lie on the same line. If they lie on the same line, we can draw a line. We can draw a line from A to B. According to Euclid's first postulate. According to Euclid first postulate, we can draw a line passing through any 2 points. If C lies in between them, C also lie on the same line. If C doesn't lie in between them, first case you can observe A and B are 2 points. According to Euclid's first axiom, first postulate, we can draw a line passing through A and B. But unfortunately, C is also in between. C is in between A and B, so it also falls on the same line. But when you see the second case, 3 points A, B, C. Okay, passing through AC, we can draw a line. Passing through AB, we can draw a line. Passing through BC also we can draw a line. Is that right? Okay. But there are 3 different lines, not same line. So, if C is on the same line, if A, B, C are on the same line, we can draw a line passing through them. We can draw only one line passing through them. if they are not on the same line, A, B, C are not on the same line, we cannot draw a same line passing through them. We cannot draw a same line passing through them. We can draw three lines. Okay, na? According to Euclid's first postulate, we can draw a line passing through any two different points. Okay, na? Is that okay, children? So 4 more questions are there. We can see those questions in the class tomorrow. Okay. Now here there ends the class. If you are not subscribed to the channel, please subscribe the channel. Subscribe the channel immediately and like the class. Click on the like button and subscribe the channel and leave. Subscribe the channel and leave the class. Click on the like button, children. Click on the like button, children. Yeah. Bye.